Hello everyone, last time I've been demonstrating the 7-layer convolutional neural network that I've trained in order to play the game of Go, but the results were not quite satisfying at the moment, so it only trained for 4 hours and reached around 17Q level. And after that I considered a slightly bigger net. So 11-layer net, I would now show the model definition. And this time I used 20,000 pro games in SGF format that has resulted in 4,260,624 training positions. And the input channels are exactly the same, so only relying on the black and white stone location on board. So without caring much about the previous moves, like in Katago, we'll talk about this. Like Atari or any other local patterns. And yeah, so that comes with a price, and I'll talk about this in a while. And this one went only for 6 epochs, so the loss I reached after training for 60 hours, like 2.5 days essentially, non-stop, is not as good as over in here. Yeah, and it essentially started dropping very slow. So I don't know, to the epoch 10, I could barely reach the, I don't know, maybe 2.7, hopefully, because last couple of epochs it was like from 2.89 to 2.83 to 2.81. So yeah, sort of a bottleneck here already. I'll share my thoughts about this as well. And yeah, so eventually it reaches, well, I would say somewhere around 13Q. That's a very rough estimate. I've been using my Katago estimate. I will show you how I estimated the plane strength and why I consider it to be like somewhere around 13Q. So in the release page, so this is the thing that you might get interested in. So a new net has appeared, so it's called TinyGoCNN 13Q. This one is really much bigger than the previous one, 160 megabytes. It's uncompressed, yeah. So that's the reason why it's much bigger than a much stronger Katago net. It's just uncompressed. It's not optimized for size. Right. And yeah, let's have a quick look at the model to give an idea about the architecture. So this was the initial net, the 17Q one. So like not very big. So here we already have the first convolution layer with the 7x7 kernel. Then we have 4 convolution layers with the kernel size 5x5. And then we have 6 layers with a convolutional size 3x3. So this is something that may look like so-called dead left 44% network, which is the one that is used in Patchy. The dead left net has 19 layers, and I tried that architecture initially, but it took me 6 hours. It took me 5 hours to train. 5 hours per 1 million positions, and there were like 4 million positions. So it would be like 1 epoch per day, and to get the same results, I would need not 2.5 days, but I ran for about 6 epochs. So I would need 6 days or something, so nearly a week to train with a 19 layer that left 44%. Yeah, so I decided to make the net a bit smaller, and these are the results. But I believe that it doesn't make that much of a sense, like the 11 versus 19 convolution layers, because here is the problem. So I just want to go back. So the problem is that when we have only 2 input channels, like only the location of black stones and white stones, and unlike the Katago that has like 20 features or something for the input, or even more. So it's very poor. It shows a very poor performance in tactics. So what's the reason for that? The reason is simple. It only thinks of strategy, and it's more like a statistical distribution, I would say. So based on the stone position, where likely would be the best move strategically, like trying to get the very end result of the game, like try to have bigger territory, yeah. But it doesn't take into account the fact that you might get killed along the way and might get captured. So it's not caring much about this. That's the problem. Yeah, that's the real problem. So I tried two types of searches. I tried the multicolored tree search, counting the stone difference as the measure of like who is better in the position, not the win-loss like in the classical multicolored research, but the difference of stones. Because with the classical multicolored approach, the first question is it's very unclear how to run rollouts, because if I run rollouts using exactly the same net, the results are not very much different from what the actual net is doing, because that's the same net. Try to handcraft your own rollouts. It doesn't quite work. Yeah, because it's just like handcrafted and it's not working either. So the most reasonable, the most decent thing I could come up with is trying to make sure that the net is trying to like literally might be treated as the net is trying to consider captures in case if it can do a capture of a big group. That's something that I try to implement with multicolored research and also with the Negamax search with alpha beta pruning, which is an overkill, I know, but those were the approaches I considered. But again, the bottleneck is the following. So I had, let's say, the first 20 moves, and the urgent move is to capture a huge group of, say, 10 stones, like the ladder. Say it chases the ladder. It doesn't chase the ladder, but say it's chasing the ladder. And then the one last move, it needs to take all the stones in the ladder, but it doesn't do that move, right? So just place somewhere else, and the opponent can escape from the ladder. And he still thinks that this is okay. The net still thinks this is okay. This is obviously not okay. This is all horribly wrong. These are the tactical like problems with the net. So how this gets resolved? But what's the problem? So the problem is that the correct move to capture the stones to complete the ladder might be like move number 20. It should be move number 1, but it's like move number 20 or something. And for the multicolored research to reach the move number 20, assuming that every move has only one play out, which is not very likely to be the case. Usually just starts the first couple of moves, even the horribly wrong, it gives like 10 to maybe 13, 15 playouts for those first two moves, and then it just runs out of playouts to get to the move number 20. So that's the problem. So multicolored research assumes to consider some move within the first top 5, maybe top 10, but not top 20 or not top 50. Yeah. So when I tried something like 200 playouts, it just starts being slow as hell. And even though rollouts were not running to the very end, but just you get the material difference, the rollout ends because it's already clear that you're kind of losing material, losing stones, without counting territory, because that would be just complete overkill. That would be just way too slow. That's the reason, by the way, why they introduced the value heads to the Katago-like engines, because the value head is very important. It helps guide in the multicolored research. That's something very trivial that I've realized these days, but yeah, that's it. But on the other hand, so it's like if you want to play against the bare net, if you don't want to have multicolored research, if you're not planning having a multicolored research, if you're looking for just training a NAT that would be playing absolutely on its own without any search to make it not as god level as Katago, let's say. In this case, you don't particularly need a value head, because value head is only makes sense when you want to guide the multicolored research. Yeah, but if you don't want to guide the multicolored research or have a search, you don't quite need the value head. It just takes longer to train and complicates the architecture. So if you're looking to play against the banner, you don't particularly need that. You may even train the Katago now, dropping the value head. That would be much faster, I believe. I think so. And if you're not going to be using the multicolored research, yeah, you just don't need the value. This brings us to the second problem, and the second problem is that in order to make sure that even if the multicolored research has nice values and all this stuff, the correct move, like taking the ladder, yeah, capturing the stones in the ladder, if this move is, even if it has a value, and if this is like move number 50 or 60, not within the top 5 moves, in this case, it would still significantly slow the search, and this is not going anywhere. This is not practical. And that's the reason why, when it comes to input planes, input channels, they use really, really, really lots of those. So, historical moves, for instance. So it gives the net, it's like in recursive neural nets at some point, it gives like timing, like what has occurred before. Not exactly, because the time is being merged into a single input, so it's like reflects the past. So it's not a sequential stuff like in recurrent neural nets, and we know there are recurrent convolutional nets, which kind of trying to combine these two concepts all together. But that would be an overkill for the game of Go. So what they do instead, they just have this additional channels where up to 4 previous moves are being masked in a yet another 19 by 19 plane. So it's all about having many 19 by 19 planes, not just 2, but having more. So one 19 by 19 plane for black stones, one 19 by 19 for white stones. Katago also uses one 19 by 19 to mask, I believe, all the stones, like regardless black or white. I might be wrong, but there is another additional one, or maybe mask all the empty squares. I don't remember. I'm sorry. Then another 19 by 19 plane to show where the previous moves were when it comes to some tactical patterns. For ladders, another 19 by 19 plane. What else? For the co, for the liberties, that's the essential one. So if you have 2 liberties or 3 liberties or maybe 1 liberty, especially, every that case has its own 19 by 19 plane. So magnifying the number of input planes to somewhere around like 13, I would say, this would already give the NAS some tactical opportunities that it can learn, that it cannot otherwise learn without those additional information. Because from only 2 planes, like black and white stones for each 19 by 19, it only gets, let's call it like statistical distribution. Like it just gives a clue to the NAT, like where to develop the stones, how particularly to play, but it completely misses the tactical stuff. And I believe no matter how deep the NAT is, so making the NAT deeper would be just better in terms of it would become more and more strategic. So in the open, it plays quite strong. Well, let's say like I'll not demonstrate, but later in the game, when it comes to this tactical complications, it fails completely. So that's the bottleneck of having only 2 input channels. But again, the more input channels we have, the longer it takes to train the NAT, because it's like way more complicated. And that's another reason why they start adding this pooling, batch normalization potentially, maybe residual connections to avoid grading, vanishing, etc., etc. So architecture of the net is getting more and more complicated if the input channels are more than just two. Although the that left 55% net, the patchy main net, it has like 13 input planes or something compared to the that left 44, which has only two, and that is a significant improvement already. And doesn't have the that left 55% doesn't have residual connections or pooling or something. That's the just fully, like, not fully connected, but just a list of the bunch of convolutional layers with different kernel sizes, and that kind of works nicely. But again, just if you try to play the dead left net versus even very early Katago net beats that because it just has more planes, and the architecture is deeper, and is more complicated. It can learn more complex patterns. Okay, guys, enough talking. Let me demonstrate this final result I came up with. So I'm starting the Go GUI. Again, for those who maybe missed the previous video, edit programs, TinyGoCNN. So I specify the current working directory. This is where I git clone the project. And then I just do Python GTP py to run the GTP wrapper. All right. So this is how it goes. So now I attach the net, and I ask the net to play both sides. Okay, yeah, the magic is happening. I really like this move, although it's probably not the strongest one, but this is something I would have played as a human player, because imagine black plays here and double peep, so not quite good. So you see, like, it tries to stay connected, which is, I think, quite impressive. White is trying to live on the side, and most likely would. I'm not sure if black plays here. Probably white is going to die then. Yeah, but anyway, this looks like a real game of Go, isn't it? Can you spot? Yeah. It would now start doing some cheaty stuff at the end. But again, that's due to the lack of tactical reasoning, unfortunately. But with such an architecture, I think the result is quite satisfying. We'll now run the Katago estimator to evaluate the game. Would give quite surprising results. I already know them. All right, yeah. So this is like not going anywhere really, but interestingly, you see, like, it's actually trying to kill black here. It's actually trying to kill black. It couldn't, but it tried to analyze this position a little bit more right in a moment. Okay, so I want to save the file to read within my GoRank estimator and run the estimator itself. Yeah, I really want to analyze this a little bit now. So there was a strategic thought behind those invasions in the corner. But first, let's have a look at this score. Okay, very imbalanced. So 5Q for black color, although black actually lost the entire this thing. And white is like only 22nd Q, which might seem to be bad, but that's because of these moves that don't quite make sense. So if we cut off the lost moves, the performance of white would be much better. So let's see what actually happened here. So the eventual idea, the white had, you see, like, white really wanted to kill, and unfortunately this doesn't work. So even if white played this, just net is running. Okay, let me stop the net. Okay, just was trying to play for both players. So even like this, even if I kind of try to win the Go, it's like not going anyways. White is actually dying. But the interesting bit here is Yeah, after playing, hold on a sec. Yeah, this is the horrible mistake. So white can simply take. So like tactical disaster. So black shouldn't be playing here. I don't know why black is evaluated as 5Q. It doesn't make sense making moves like this. But what is even more interesting, yes, that over in here, so like white doesn't understand this cannot be killed, but white actually tries to kill this, and then black can also die at the very end. So essentially, I think white should have won this game, not black, because you see, like, just kills a whole lot of stones. So this position, I think, would definitely be favorable for white. But yeah, Katago likes black performance overall. So a little bit of an experiment. If we truncate the moves at this stage, so just get rid of the moves here and save the game again and run the estimator. Now would be something around somewhere around 16Q for white, so not 22nd Q, because all these moves are not plausible. All these moves drop in the evaluation. So because all this is just the mean value, so these numbers are like Katago move choice number 1, move choice number 101. Yeah, 18Q. Sometimes it's evaluated as 16Q, but it's not the 22nd. So this is a little bit better. So before white started this disaster, this is a little bit better for white. Yeah, so this value is the mean of all these values across the game. Maybe not the most accurate way to count to calculate the strength, but it works quite nicely intuitively, and it really often matches the actual playing strength, especially when I evaluate my own games against human players. It's really like to be the case. Yeah, right. So now let's run a couple of experiments. So the new game, and I want to run the Chinese opening. The results here would not be satisfying in terms of um, results like good scores, but it's interesting to see how he thinks, how the ideas are arising here. Like too small here, I believe. Yeah. But I think this really looks like a Q game. It's pretty meaningful, generally, I believe. At very least, compared to the smaller node that I've been demonstrating in the previous video, I think this makes way more sense. By the way, yeah, there was a tactical shot over in here. If blocks, then just takes. Again, it misses tactics completely due to very poor input data to the net. So the net knows nothing about tactical patterns at all. But it all comes with the price of the training speed. Yep. Yeah, I really like how it started within this version of the net. It really starts this meaningful invasions with an idea to kill opponent, which makes sense to me. It's not very plausible, but the ideas, really love them. So this would unfortunately be evaluated at 22nd queue for both players or something, if I'm not mistaken. And by the time it's running, I just want to start a new game. And I'll also show you how it performs with the Sunrun site, which is interesting, yeah. Okay, let me wait until the evaluation of the previous one works. Yeah, so here we got, 25, 23rd queue, so this is quite poor. And you see like what happens to evaluation. That's because of these tactical vulnerabilities. But up until move 150, it was quite okay, see? I think this score, if truncated to 150, would be much better. But unfortunately I deleted the, okay. the previous game. We can restore it, but okay, never mind. Try on this one. Try to truncate to where before the tactical disaster would start. Yeah, here it doesn't play this move, interestingly. I think it's okay about it. Yeah. It's a very human-like exchanges over in here, I believe. It's interesting, yeah. I really like how they play out the Sunruns, hey? Although not very classical, probably human player would never load this. Well, if he is double digit Q, then probably he does, but if he knows why to play Sunrise, he probably doesn't want to go this way. And this just visually looks quite even to me. Probably black is better. Yeah, probably black is better. Or maybe, I don't even know. Let's see the final score for the game. This was a horrible mistake. Yeah, actually white is dying. Taking away Tonai, it doesn't make sense at all. But yeah, if it didn't, I think that could be much better if it didn't do that. Sometimes you see like tactical things are working, so you just can't capture the group. On the other hand, capturing this group didn't probably make much of a sense because it was dead anyway. So like captures when it doesn't make sense and doesn't capture when it makes perfect sense for some reason. Again, for the reason of having a poor input plane. Okay, let's evaluate this one. And here, if again this tactical noise starts, I try to truncate the game to the state before that and to evaluate kind of a pure strategic outcome of the game, I would say. Yeah. Let's have a look. 17Q black versus 24Q white. Yeah, not very good. Not very good. Okay, maybe up until move 200s. Yeah, I think this was quite okay up until over in here. Although the win rate, look at the win rate. The score was okay, but the win rate, oh my goodness, wasn't. Yeah, actually, most of the disastrous moves were made in the opening. Whoa, that is interesting. Most of the disastrous moves have been made in the opening. So let's truncate to up to move 200s. The move 200s. This is move 200s. Okay, let's truncate here. And run one more time. I don't know if this is going to change much, but at very least, evaluation-wise, score-wise, it was more or less even up to this point. Not the win rate-wise, though. Okay, 22nd Q both. So, yeah, because of this noise. Yeah, because of this noise, this is so bad. But let's say we truncate to move number 25, and it would be the dramatic change. It would be really, I probably can go home. Okay, it doesn't work that way. Let's go to the beginning. So move number 20 as to up until this one, essentially. So just the opening, the very early opening. Let's see. I'm now playing a game myself against this net, and I would be showing the evaluation goals. Oh, black 4 done, white 6 done. Yeah, not that bad, right? So over in here, it's like quite good. It's actually quite good. But yeah, then it goes to tactical disaster, and the mean value of the main representation of the plane strength obviously drops down. Okay, new game. I want the computer to play, so I give him, like, he's weaker, so he let him play black. Okay, and approaching my corner. I'll probably want to play here. This is solid. So where I want to develop to this side, so I go from here. Can probably go for this. Can probably go here. I'm not quite sure. I probably did something horribly wrong. Okay. Yeah, and already, so like the tactical disaster is going to happen now because a whole lot of weaknesses. So before this, let me save, and I want to see what Katago thinks of this position. Okay, yeah, I'm like 6 he's like Fatinki already. Yeah, okay, I just didn't give him a chance there. Let's start over. The repositions where he does much better. So I try not to exploit his weak points out of start. So computer color black. I just try not to. I just try to play normally. Okay. I just try to play kind of normally. Can I play this? Probably I couldn't, but I just want to let him play some Joseki just to show you that he's completely aware of what the Joseki is. Man, what are you doing? Come on. Although it's not necessarily good. So it like starts. Okay, I just give him everything he would ever dream of. I would give him a fantastic huge moyo, right? I would give him a very, very big moyo. Where else? Where else to play? Yeah, I just want to make sure he's building this huge moyo. Okay. Right. Okay, just making stupid moves. Yeah. Is this? Wow, did he just? Oh, come on. Really? You could play dun dun dun. Okay. Yeah, I think he could kill this one. But yeah, fortunately he knows nothing about tactic. So this is clearly a winning position for black. Let's see. So you should never play like this. But I just wanted to give you an idea, like in regards to his strong parts, like that he can build. If you're playing stupid passive moves, not trying to fight for the entire board, and just try to make territories, it just takes the entire center. TinyGoCNN, yeah, third queue, and I'm like 26 queues. I'm doing horribly bad here. And this is like move number, how much? Move number 105. But I would now show you that this is actually going to end up as a complete disaster for him quite soon. Okay, this is already dead, yep. Okay, cat in everywhere, he knows nothing about this. He knows nothing about that, yep. Alright, then try to kill things. Yep. Try to kill things, yep, he should have played this one. Probably he shouldn't, yeah. And just kill. I blundered. I misclicked. Okay, let's then try to kill this all somehow. Yeah, let's kill this all. Let's kill this all. Yeah. So yeah, it's very stupid actually. Very, very stupid. I think I can kill every single stone here. Well, maybe not every single stone, but it doesn't even do this. Come on! You see what is stupid? He should have taken, but he just gives up everything. Absolutely. He just gives up everything. Can you see? Yeah, it just gives up fucking everything, yeah. Right, yeah, this is unfortunate, surely. You see? Just doesn't care much. I think I can even try to somehow, I don't know. Yeah. You see, it's very vulnerable to tactics, so essentially gives up all the stones that he has. All the stones that he has, just gives those up. Alright. Yeah. I cannot believe you did this. Yeah. Cool. So if we just, so this is clearly winning for whites now. If we save this one, it would now show that from third queue, yeah, it would now drop to somewhere very low value. My value would still suck because, yeah, this moves that I made should never actually work in real life, so they are not considered to be strong. So Katago is not going to be evaluating those moves as good moves, I believe. Yeah. So just want to show you the downside of this net. And still he thinks, so Katago is like 6Q, so still better. Well, I got promoted from 22nd to 16Q. But yeah, realistically, this is like, it's not going anywhere. So like y plus 58.5, this is absolutely hopeless. But still, he thinks that the knight was generally doing kind of good moves, although these tactical blunders are so horrible. But probably he did occasionally good moves over the. Although not all the good moves, it's still the outliers here. This outlier, this one, and also this one. Yeah, so it's kind of goes like this. But definitely, like when we have two nets where the first, the tiny net with only 7 layers, around 17Q, and this one, so tactically they both suck, but strategically this one is much, much, much better than this one. So black, let it be GTP 17, the pi. So 17Q net is going to be playing black, and 13Q is going to be playing white. Now hold my breath, and I try to run this one. It should say GTP 17 versus GTP or something, or TinyGoCNN with capitals versus the one with dashes. Okay, just Go GUI. Okay, computer color both. Yeah, one is doing stronger, just thinking longer. The white is thinking longer. And the black is thinking faster. Yeah, this is exciting. Yeah, so 13Q net is now playing white. 13Q net is now playing white. Yeah, it's clearly that it has a huge advantage, you see, strategically outplaying its opponent. But what about tactics? We'll now see. What about tactics? And to evaluate this game is also interesting, yeah. Yeah, it's actually, black is killing everything. It's interesting. Okay. Oh, fuck. I'm really intrigued. Okay. Let's see. Desktop estimate rank. So white is supposed to be better. So white player was the 13Q. Black player was 17Q net. as I think of them. So the bigger net is white, the smaller net is black. We can play vice versa, basically. Okay, so results. So white won by 38 points, which makes perfect sense. But from the perspective of how they moved, so black is 22nd queue and white is only 21st queue. So like according to Katago, they both suck, yeah? Okay, but they both suck move-wise, but actually stronger Nat, bigger Nat won the game, and this is what I've been expecting for. So plus 38. This is how would 13Q win against the 17Q with this score? This makes perfect sense to me. All right, now let's try the opposite. And probably we end up there because this would last forever otherwise, I believe. And it programs to GTP. So now make the opposite. So this time, Strong Knight is playing black. Okay. Now, Strong Knight is going to be playing black. All right. Yeah, it looks like a complete strategic domination already. It takes the whole center, takes everything. Although, yeah, let's invade in the Moyo. Interestingly, yeah, you know, like the weaker net is also interesting. Actually, it's like compared to Katago thinks they're the same in strength. Yeah, but it's clearly seen that the bigger net is actually winning. So it has a lot of territories, and the white net, the small net is very poor. Okay, and this all is going to just die. I hope Strong Net is going to take away Tonai. Yeah, a nice try, but it's all dead actually. Yeah, it's actually all dead. Yeah, cool. This is cool, yeah. This is really cool. They keep playing. Whoa. Yeah, what a game! What a game! A clear domination by black, but let's see how this is going to evaluate. Okay, now this makes way more sense to me. So like the strong net is now evaluated as the 8Q, and the weak one as the 33rd Q. And yeah, this actually reflects the actual difference in playing rank. Although the score is not very much different from the previous game, but yeah, now Katago really likes more the stronger, bigger net. Mean performance much better compared to the previous time. So it's like, yeah, much better this time. So yeah, guys, I think that it did make sense to spend processing power 2.5 days to train this second net 11 layer net, because the results are actually speaking for itself. So yeah, thanks for watching. This is from my side. Hope to see you next video. Until then, and cheers.